Hello, we're going to look at a topic in solid mechanics 2, in particular temperature stresses. So in this question, I have a problem that you're going to solve. It consists of a composite bar with member A and B in between a gap G of 0.2 millimeters. Then the given data, diameter of A and B, Young's modulus, length. This is the symbol for the coefficient of temperature for both A and B. Then stress sigma A should not exceed 200 meganewtons per meter squared, and the stress in B should not exceed 120 meganewtons per meters squared. So we are told find the change in temperature. So let us solve that solution. Now, the free expansion is equals to compression of a member. So that is our starting point. Free expansion is equals to compression of a member. So how do we get free expansion? Free expansion is given by the formula coefficient of temperature multiplied by length multiplied by the change in temperature is equals to compression of a member. So to get compression, we are talking about the change in length. So back to our formulas, strain is given by change in length all over original length. Also, strain is given by stress all over Young's modulus. So we can combine the two such that change in length over length is equals to stress over E multiplied by length multiplied by length. I'm left with change in length is equals to stress all over E times length. Now stress is given by load over area. So that would be my load P divided by area E times Young's modulus multiplied by L. So that is going to be my change in length. So this is now the formula that I'm going to use for the compression of a member. So let me write it up here. It's given by P L all over A E. So since we have two members, this is going to be given by coefficient of A times the length of A multiplied by the change in temperature of A plus coefficient in B times the length of B, change in temperature of B is equals to, so here for the compression I forgot to input the gap, this distance G, so equals to the gap G plus P L all over AE for both members A and B. That is just a short form because of the limited space I have. So let us solve this first part of our equation. We solve the first part. So this is going to be given by stress. Stress in A is given by 1.8 times 10 to the power negative 5 multiplied by the length in A is 1.5 meters, that plus the stress in B is 1.5 times 10 to the power of negative 5. The length in B is 2 meters. Then the both of them, I shall multiply them with the change in temperature. Since it's a composite bar, they're going to have the same change in temperature. So with that, I have a calculator nearby. 1.8 times 10 to the power negative 5 times 1.5. That is going to give me 2.7 times 10 negative 5, then the other part 1.5 times 10 negative 5 times 2. I shall have a 3 times 10 to power negative 5 change in temperature. So the sum of that is 5.7 times 10 negative 5 change in temperature. So we have solved for the first part of the equation. So let us now solve for the second part. So bear in mind of these parts. Allow me to rub. Now for the second part, it is gap plus load L, the area of A, E of A, length of A, plus load the length of B all over area of B, E of B. Notice that in the load part I've not included either A or B. So what does that mean? We have to find the least possible load that these two members can support. So we find the least possible value, the least value for the load P. Now, back to our formulas, we know that stress is given by load over area. So that means load will be given by stress times area. Now, if we consider the stress in A should not exceed 200 meganewtons, so we're going to consider the load is given by the stress in A times area of A. So let us first find the area of A. The area of A is going to be given by, we have the diameter, it is a circumferential, so that is going to be given by pi r squared, and I shall have pi times, this is the same as saying pi d squared over 4, so 60 millimeters, 0.06 meters squared all over 4, and that will give me 0.06 squared shift pi divide by 4, 2.827 10 negative 3 meters squared. That is the area of A. So to get the load, I shall have stress in A should not exceed that. So assuming it's A, 200 meganewtons, 10 to the power of 6 times 2.827 10 to power negative 3. So once you evaluate that to the power of 6, you shall have 565.49 kilonewtons. So that is the load when we take the value of stress to be 200 meganewtons. So what if we take the value of stress not to exceed the 120 meganewtons? So back to these points. So once again, stress will be load will be given by stress in B times area in B. Area in B, pi d squared over 4. Pi, the diameter in B is 80. 0.08 squared over 4 equals to shift pi divided by 4, 5.027 times 10 to power negative 3 meters squared. So the load will be given by stress in B, 120 to the power of 6 times 5.027 10 to the power of negative 3 and that will be 603.19 kilonewtons. All right, so we now have two values for load. One is 565.49 kilonewtons, the other one 603.19 kilonewtons. And we have said that we are going to consider the least possible load. So between the two, that is the least value. So our value for P is going to be 565.49. Therefore, the formula that I had was gap P LA, area of A, the E of A, plus P LB, area of B, the E of B, whereby the value for P is 565.49 kilonewtons. All right, so with that we substitute 0.2 millimeters when it's convert 0.2 to power negative a third plus the load 565.49 to the power of a third times the length in A 1.5 divided by the area in A. Area in A, allow me to read the value. Area in A 2.827 times 10 to power negative a third. The E of A 210 times 10 to power 9 plus, now for the second part, the load 565.49 cubed times length in B is 2 all over area of B 5.027 10 to power negative a third. Young's modulus of B 150 10 to the power of 9. So once you evaluate that, you shall have 0.2 times 10 to power negative 3 plus 1.429 times 10 to power negative a third plus 1.5 times 10 to power negative 3. Now with that, add all the 3.129 times 10 to power negative 3. So back to where we were. So this was for both A and B, and also this was for both A and B. So that is going to be equal to 5.7 times 10 to power negative 5 change in T equals 3.129 times 10 to power negative 3 divided by that divided by 5.7 times 10 to the power of negative 5, and with that the change in T is equals to 54.89 degrees Celsius. So we have solved the questions. Find the change in temperature, that is 54.89 degrees Celsius. If there are any questions that you have, kindly write them down below in the comment section. Thank you.